Section 1. The hidden problem inside customer data. Organizations collect enormous amounts of customer data every day. Purchases, website visits, service interactions, support tickets, loyalty activity, and marketing responses all create valuable information. The challenge is not collecting data. The challenge is understanding it. When a company has 100,000 customers, no executive can manually identify meaningful patterns. The result is often generic strategies that treat every customer the same. Important differences between customers can become hidden inside millions of rows of data and hundreds of variables. This is where K-means clustering becomes valuable. It helps organizations move from overwhelming amounts of information to a smaller number of meaningful customer groups that can actually be managed and acted upon. Section 2. Why K-means was invented. K-means was created to solve a simple problem. How do we automatically discover groups hidden inside large data sets when nobody knows the groups beforehand? Instead of searching for individual customers, K-means searches for patterns among customers. It allows organizations to find naturally occurring segments that would otherwise remain invisible. Rather than relying on intuition or assumptions, leaders can use data to uncover the true structure of their customer base. This often reveals opportunities and risks that traditional reporting may never expose. Section 3. What makes data difficult to understand? Customer data rarely exists in a single dimension. A customer may differ by revenue, frequency of purchases, support costs, tenure, loyalty, engagement, and dozens of other factors. Humans can understand 2 or 3 dimensions. Organizations often manage hundreds. As the number of variables increases, it becomes increasingly difficult to recognize meaningful patterns using spreadsheets or dashboards alone. K-means helps simplify complexity by grouping similar customers together. Instead of analyzing thousands of individual customers, analysts can focus on a handful of meaningful segments. Section 4. Our enterprise example. Throughout this video, we will use a single business example. A company with 100,000 customers wants to identify high-value customers, growth customers, at-risk customers, new customers, low-engagement customers. Every concept, dashboard, AI workflow, and Python example in this video will use this same scenario. Using a single example allows us to follow the complete business journey from raw customer data all the way to executive recommendations and strategic decisions. Section 5. What is K-means clustering? K-means clustering is an unsupervised machine learning technique. Unsupervised means there are no predefined labels. Instead of being told which customers belong to which category, the algorithm discovers the groups automatically. The objective is to place similar customers into the same cluster while keeping different customers separated. Think of K-means as a data-driven way of identifying customer communities that share similar characteristics and behaviors. The result is a simpler representation of a complex customer population. Section 6. How K-means works. Conceptually, K-means begins by selecting a number of clusters represented by the letter K. The algorithm places temporary cluster centers called centroids. Customers are assigned to the nearest centroid. The centroids then move to better positions. This process repeats until the groups stabilize. The result is a set of customer segments based on similarity. In practical terms, the algorithm continuously improves its understanding of the data until each customer belongs to the group that best reflects its characteristics. The final clusters represent the natural structure hidden within the dataset. Section 7. Business value of clustering. Clustering transforms raw data into actionable business insight. Instead of managing 100,000 customers, leadership can manage 5 meaningful customer groups. This simplifies strategy, resource allocation, budgeting, marketing, and customer retention planning. Different segments often require different investments, different messages, and different success metrics. Clustering helps organizations prioritize resources where they can generate the greatest business impact. Section 8. AI helps define the business problem. Before running K-MEs, organizations must decide what business problem they are trying to solve. Tools such as ChatGPT, Gemini, Copilot, and Claude can help analysts clarify objectives, identify stakeholders, and translate business questions into analytical requirements. AI can also challenge assumptions and suggest alternative perspectives that analysts may not initially consider. A clearly defined business problem often determines whether a clustering project succeeds or fails. Section 9. AI-assisted feature selection. AI can recommend variables that may be useful for clustering. Examples include annual revenue, purchase frequency, customer tenure, support costs, website engagement, and marketing response rates. AI does not replace business expertise. It accelerates the discovery process. By evaluating business context and available data, AI can highlight variables that are likely to explain meaningful customer differences. This helps analysts begin with stronger candidate features. Section 10. AI Data Quality Review. AI can identify missing values, inconsistent fields, duplicate records, and potentially useful variables that analysts may overlook. Better data quality leads to better clusters. AI can also flag unusual patterns, outliers, and potential data integrity concerns before analysis begins. Fixing these issues early improves both the reliability and credibility of the final results. Section 11. AI recommends clustering strategies. AI can suggest possible segmentation approaches: behavioral segmentation, value segmentation, risk segmentation, lifecycle segmentation. These recommendations provide useful starting points before analysis begins. Different segmentation strategies answer different business questions. AI helps analysts quickly evaluate which approach is most aligned with organizational goals. Section 12. Preparing data in Python. The workflow typically begins with Pandas. Customer records are loaded, reviewed, filtered, and prepared for analysis. Clean data forms the foundation of reliable clustering. This stage often includes validating fields, correcting errors, removing duplicates, and creating new analytical variables. The quality of the preparation phase has a significant influence on the quality of the final clusters. Section 13. Selecting variables. Not every variable belongs in a clustering model. Analysts choose variables that describe meaningful customer behavior and align with business objectives. Including irrelevant variables can dilute important patterns and reduce the usefulness of the results. The goal is to select variables that help distinguish one customer group from another in meaningful ways. Section 14. Why data scaling matters. Variables often use different units. Revenue may range into thousands, while engagement scores may range from 0 to 10. Scaling ensures no single variable dominates the clustering process. Without scaling, large numerical values may exert disproportionate influence on cluster assignments. Scaling helps create a fair comparison among variables and produces more balanced results. Section 15. Choosing K. One of the most important decisions is selecting the number of clusters. Too few clusters oversimplify reality. Too many clusters create confusion. This is where the elbow method becomes useful. The chosen value of K influences how detailed or simplified the final customer segmentation becomes. Finding the right balance is essential for generating actionable business insights. Section 16. The elbow method. The elbow method evaluates clustering performance across different values of K. Analysts look for the point where improvement begins to slow significantly. That point often provides a reasonable balance between simplicity and insight. Rather than selecting K arbitrarily, analysts use data to support the decision. This creates a more objective and defensible segmentation strategy. Section 17. About running K-means. Using Scikit-Learn, analysts run the K-means algorithm and generate cluster assignments for every customer. Each customer is assigned to the segment that most closely matches its characteristics. The model calculates similarities, updates centroids, and iterates until stable clusters are formed. At the end of the process, every customer receives a cluster label that can be used for further analysis and decision-making. Section 18. Visualizing clusters. Matplotlib and other visualization tools help reveal customer groups. Visualizations often make clusters easier to understand than raw tables. Charts and dashboards allow analysts to identify differences in value, behavior, risk, and engagement across customer segments. Visualization is often the point where clustering results become understandable to business stakeholders. Section 19. Executive dashboard concepts. Clusters become most valuable when incorporated into dashboards. Executives can monitor revenue, retention, profitability, engagement, and growth opportunities by customer segment. Instead of reviewing organization-wide averages, leaders can evaluate performance within each customer group. This supports more targeted decisions and better resource allocation. Section 20. AI names the clusters. AI can analyze cluster characteristics and suggest intuitive business names. High-value customers, growth customers, at-risk customers, new customers, low-engagement customers. This improves communication with stakeholders. Meaningful names help transform technical cluster IDs into concepts that executives can easily understand and discuss. Section 21. AI explains the clusters. AI can summarize key differences between customer groups and explain why the segments matter. This saves analysts considerable time and improves stakeholder understanding. AI can highlight the defining characteristics of each segment and connect those characteristics to business outcomes. This makes the results more actionable and easier to communicate. Section 22. AI generates executive summaries. Instead of manually writing reports, analysts can use AI to create executive summaries, recommendations, and action plans. The focus shifts from reporting data to making decisions. AI can rapidly transform technical findings into business language that resonates with executives and stakeholders. This accelerates the transition from insight to action. Section 23. AI creates recommended actions. AI can suggest retention campaigns for at-risk customers, upsell opportunities for high-value customers, and engagement initiatives for low-engagement customers. It can also recommend success metrics, campaign priorities, and resource allocation strategies. These recommendations help organizations operationalize clustering insights and drive measurable business value. Section 24. K-means versus classification. Classification predicts known categories. K-means discovers unknown categories. Classification answers who belongs where. K-means answers what groups exist. Classification requires historical examples with predefined labels, such as customers who previously churned or customers who previously purchased a product. K-means works when those labels do not exist. In many organizations, K-means is used first to discover customer segments, and classification models are later used to predict which customers belong to those segments in the future. Section 25. K-means versus regression. Regression predicts numbers. K-means discovers segments. One forecasts outcomes, the other reveals structure. Regression might predict customer lifetime value, future revenue, or probability of churn. K-means focuses on understanding how customers naturally group together based on their characteristics. Organizations often use both methods because understanding customer segments can improve the accuracy and usefulness of predictive models. Section 26, K-means versus PCA. PCA reduces dimensions. K-means creates groups. PCA simplifies variables. K-means simplifies populations. The two methods are often used together. PCA helps reduce complexity by combining many variables into a smaller number of components while preserving most of the information. K-means can then use those simplified components to identify meaningful customer segments more efficiently. Together, they form a powerful combination for exploratory analytics. Section 27, K-means versus Topsis. Topsis ranks alternatives. K-means groups similar observations. Ranking and clustering solve different business problems. Topsis helps answer questions such as which supplier, project, product, or investment option is best. K-means helps answer questions about what groups exist within a data set. One method prioritizes alternatives, the other discovers structure. Both can be used together to improve business decision-making. Section 28, K-means versus predictive AI. Predictive machine learning forecasts future outcomes. K-means describes current structure. Many organizations cluster customers first and then build predictive models for each segment. This allows organizations to create more specialized and accurate predictive models. Different customer segments often behave differently. Understanding those differences before building predictive models can significantly improve business performance and forecasting accuracy. Section 29, turning clusters into strategy. Clustering alone creates no business value. Value emerges when insights drive decisions. Each customer segment should have a corresponding strategy, budget, owner, and success metric. Without action, clustering remains an analytical exercise. With action, clustering becomes a business capability. The most successful organizations connect customer segments directly to strategic initiatives, operational plans, and measurable outcomes. Section 30, boardroom recommendations. High-value customers require retention investment. Growth customers deserve expansion opportunities. At-risk customers need intervention. New customers require onboarding. Low-engagement customers need reactivation campaigns. This is how clustering becomes business strategy. Each segment receives a different treatment because each segment contributes differently to business performance. The objective is not simply to understand customers. The objective is to improve outcomes by making smarter decisions for each group. Section 31, executive storytelling example. An executive summary might read, we identified 5 customer segments. 20% of customers generate 60% of revenue. 15% show elevated churn risk. Targeted actions could increase retention and improve profitability. This transforms analytics into a business narrative. Instead of presenting technical charts and statistical outputs, leaders receive a concise explanation of what is happening, why it matters, and what actions should be taken next. That is the essence of executive storytelling. Section 32. When to use K-means. Use K-means when you need to discover natural groups within data. Customer segmentation, market segmentation, product categorization, operational analysis, risk segmentation. These are ideal use cases. Any situation involving large numbers of observations and unknown group structures may benefit from clustering. K-means is particularly useful when organizations need to simplify complexity and uncover actionable patterns hidden inside large data sets. Section 33. When not to use K-means. Avoid K-means when clusters are highly irregular, when categories are already known, or when data quality is poor. No algorithm can compensate for fundamentally flawed data. K-means also assumes that clusters are relatively compact and well separated. When those assumptions are violated, other techniques may be more appropriate. Understanding the limitations of K-means is just as important as understanding its strengths. Section 34. Common mistakes and cheat sheet. Common mistakes include selecting the wrong variables, failing to scale data, choosing inappropriate values of K, and treating clusters as permanent truths. Think of clusters as business hypotheses, not absolute facts. Customer behavior changes, markets change, business conditions change. As a result, clustering should be reviewed and updated periodically. The best practitioners continuously validate assumptions and refine their segmentation strategies over time. Section 35. The mathematics behind K-means. At its core, K-means minimizes the distance between observations and their assigned cluster centroids. The objective is to reduce within-cluster variation, while increasing separation between clusters. You do not need to understand every mathematical detail to benefit from K-means. Executives should focus on business outcomes, while analysts ensure methodological rigor. From a business perspective, the mathematics simply provides a structured way to group similar customers together and separate customers who behave differently. The real value comes not from the formula itself, but from the decisions that become possible once meaningful customer segments have been identified. This is why K-means remains one of the most widely used clustering techniques in analytics, machine learning, and business intelligence. Section 36. A call to action. Congratulations! You now understand what K-means clustering is, why organizations use it, how AI can accelerate the process, and how Python can transform raw customer data into meaningful business insight. But knowledge alone does not create value. Action creates value. The organizations that gain a competitive advantage are not necessarily the ones with the most data. They are the ones that consistently turn data into decisions and decisions into results. As you move forward, remember the workflow we discussed throughout this video. Define the business problem, prepare the data, analyze the patterns, make informed decisions, and most importantly, take action. Whether you are a project manager, business analyst, data scientist, executive, or simply someone interested in analytics, the opportunity is the same. Use data to understand reality. Use AI to accelerate insight. Use analytics to reduce uncertainty. And use sound judgment to create meaningful impact. If you found this video valuable, consider subscribing to support future content covering analytics, artificial intelligence, optimizations, decision science, Python, and practical business applications. Thank you for watching. This is SRR Strategic Intelligence. Until next time, keep turning complexity into clarity, insight into action, and data into better decisions. Thank you for watching. You have taken the next step toward turning customer data into insight and insight into measurable business impact with K-means. Continue building your analytics toolkit with PCA, Topsys, AI-powered analytics, Python, optimization, and decision science. If this video was valuable, please like, subscribe, share it with someone who works with data, and leave a comment with the next topic you would like to see. This is SRR Strategic Intelligence. Better data, smarter decisions, stronger results.